It looks like a digital pet, but in the last few months, social media has branded the Flipper Zero a master key for the wireless world. Viral clips show users standing near digital gas station signs and wirelessly hitting a button to manipulate the numbers on the display. In pharmacy aisles and department stores, others have documented themselves hijacking public address systems to trigger customer service announcements. Perhaps most famously, owners are filmed walking through parking lots, triggering the charge port covers of passing Teslas to flip open remotely. Border agencies in the US, Brazil, and Israel responded by seizing shipments of the device, treating the gadget as a threat to national security. So this raises a question of whether we are looking at a dangerous new weapon or a tool that simply highlights the massive holes in our existing infrastructure. The radio hardware powering these viral stunts is a Texas Instruments chip that has been commercially available since 2007. Anyone can replicate these exact capabilities by connecting a $10 radio board from Amazon to a standard Raspberry Pi. This diagram shows a rolling coat system, the primary defense used by the modern auto industry. The car and the key fob exchange a specific mathematical sequence that changes with every single use. Once a code is used to unlock the door, it is instantly invalidated by the receiver. Because the flipper cannot predict the next cryptographic sequence, it cannot steal a modern car. More powerful tools like the HackRF have existed for years and can bypass these systems by jamming signals while simultaneously recording them. The flipper is actually designed to avoid breaking these protocols. These sub-GHz features don't introduce a new vulnerability. They provide a low-cost way to demonstrate why we need to retire static code legacy systems. The device also handles low-frequency RFID, which allows for the quick cloning of unencrypted, older keycards used in many apartment buildings. This has practical legal uses, such as scanning a lost dog's microchip to identify the registration agency and return the pet to its owner. However, the hardware hits a wall against modern encryption. It cannot read the high-security chips found in modern passports because they require specific cryptographic keys to access. When scanning a tap-to-pay credit card, the device can see the card number, but it cannot access the CVV or zip code needed for most fraudulent purchases. Most of us already carry this hardware. The NFC chip in a standard smartphone has the same ability to interact with transit cards or emulate tags. Basic modern encryption renders the device ineffective, proving it is only a threat to systems that lack standard security. Using BadUSB mode, the flipper identifies as a keyboard to a computer, allowing it to rapidly type out pre-written malicious scripts. The external pins on the top of the device allow for add-on boards that can wirelessly hijack older, unpatched computer peripherals like mice and keyboards. In terms of script execution, it is significantly slower and less stealthy than dedicated tools like the USB rubber ducky. Its real advantage is the mobile app, which allows an attacker to control the device remotely from their smartphone via Bluetooth. An attacker could hide the flipper behind a computer tower and send distant commands from a smartphone without ever touching the target machine again. The flipper's success comes from its user interface, which turns fragmented, complex hardware exploits into a cohesive and accessible experience. The Flipper Zero functions as a handheld interface for the invisible radio signals that manage our daily lives. Its massive crowdfunding success shows a clear public desire to peel back the curtain and understand how these wireless systems actually function. It is a low-cost tool for penetration testing, allowing the average person to verify the security of their own home or office. Blaming the device ignores the root cause of the problem. Companies are still selling hardware that relies on security protocols from the early 2000s. The existence of the flipper should encourage us to update our locks and demand modern cryptographic standards from our service providers. Ultimately, the device shows us that many of the systems we trust are currently protected by nothing more than the hope that no one is looking.